Hello student. So today we are going to study about the classification of crystalline solid. Now crystalline solid, as you know, that in crystalline solid the particles are arranged in long ordered arrangement. So the constituent particle here in crystalline solid, they are long ordered. Okay, they are in long ordered arrangement. Okay, these are in long ordered arrangement. Now what are the classification of these types of solid? What is the classification of crystalline solid that we learn about in this video? Now first say that broadly speaking, the crystalline solid can be classified into four types. One is the molecular solid, okay. The second one is the ionic solid. The third one is the metallic solid, and the fourth one is the covalent or the network solid. Now what is molecular solid? So the molecular solids are those solids in which the constituent particles are molecules. Molecules. These are constituent particles are molecules. Okay. So in case of molecular solid, the constituent particles are molecules. For example, say I2, that is iodine. The constituent particles are molecules. The solid carbon dioxide, that is dry ice. In that case also the constituent particles are molecules. So the crystalline solid where the constituent particle exists in form of molecules, those are classified as the molecular solid. Now this molecular solid, this can also be further classified into three types. So what are these? So first one is the non-polar molecular solid. Non-polar molecular solid. Second one is the polar molecular solid. Polar molecular solid. And the third one is what? The third one is the hydrogen bonded molecular solid. So these are the three types of molecular solids that we have. Now what is non-polar molecular solid? The solid in which the constituent particles are non-polar. That means there is no polarity difference between the constituent atoms of that molecule. So those types of solids are classified as non-polar molecular solid. For example, say I2 that is iodine, okay, or the solid hydrogen. If the hydrogen is solidified at a very high pressure and low temperature, then here it behaves as a non-polar molecular solid. Chlorine also, the chlorine can also be solidified at very high pressure and low temperature. So these types of solid in which the constituent particles are molecule, those types of solids are classified as non-polar molecular solid. Now what is the specialty about this? So since this is a non-polar molecule, so obviously a weak van der Waals force of interaction will be operative. Okay, so in this case the van der Waals force of attraction, weak van der Waals force of attraction is operative among the molecules. Now let us come to the next one, that is the polar molecular solid. Now in this case the polar molecular solid, in this case the molecules are polar molecules. For example, say HCl. Okay, so solid HCl. For example, say SO2. Okay, solid sulfur dioxide. So in this case you see that these molecules HCl or SO2, these are polar molecules. For example, another example is NH3, solid NH3, solid ammonia. So these types of solid in which the molecules are polar, they are classified as polar molecular solid. Now since the molecule is polar, so here in this case relatively stronger dipole-dipole interaction will be operative in between the molecules. So this will have greater stability as compared to the non-polar molecular solid where the weak van der Waals force of attraction was operative. Now next, the last one of this molecular solid is the hydrogen bonded solid, operative in between the molecules. So strong hydrogen bonding means, say, the what would be the example? HF, solid HF, where the hydrogen bonding will exist in between the hydrogen atom of one molecule and the fluorine atom of the other molecules. For example, say HF. So here the hydrogen bonding is operative. Okay, and obviously you have delta minus charge on fluorine and delta plus charge on the hydrogen, because fluorine has more electronegativity. So here the fluorine will have delta minus charge and the hydrogen will have delta plus charge. So here the strong hydrogen bonding is operative in between the molecules. Another example, say water, that is ice in solid form, that is ice. In ice, the water molecules are associated by the help of hydrogen bonding. So this is also an example of hydrogen bonded molecular solid. Now the next one, the next category is the ionic solid. So ionic solid, that you all know, that is the ionic salt. So for example, say NaCl. NaCl is an ionic solid. NaCl is an ionic solid. So for example, say NaCl is an ionic solid. KCl, AgCl. Okay, so all these are ionic solid. So here in ionic solid, what you can see that the constituent particles are in form of ions. So that is cations and anions. So when a large ion existing between the constituent particle is a strong electrophoretic force of attraction. So that is why these types of solid, since they have strong electrophoretic or the electrostatic force of attraction, so they have a very high melting and boiling point. Now the next category of crystalline solid, that is the metallic solid. So metallic solids are those solids in which the metallic bond exists in between the constituent particles. So suppose these are the constituent particle of the solid, and within this, suppose these are the constituent particles of the solid, and within these constituent particles the metallic bond is existing. Okay, so these types of solid in which the constituent particles is held by metallic bond, those types of solid are called the metallic solid. For example, say that sodium, copper, silver. Okay, these are all metallic solid in which the metallic bond exists between the constituent particle. Now the last one, that is the covalent or the network solid. So what are these types of solid? So this is a special types of solid in which the constituent particles are atoms, and these atoms are linked to the neighboring atom by strong covalent bond. So since they have strong covalent bond, since the constituent particles have strong covalent bond between them, so these types of solids are very hard and they are very difficult to break. Now example of these types of solid is diamond, you can say diamond, graphite. Okay, so these types of solid comes under this category of covalent or network solid. Now if you see the structure of diamond, what you will see that a single carbon, okay, a single carbon is linked to four other carbon in its neighborhood. So this carbon is also linked to 4 different carbon in its neighborhood. Similarly, this carbon is also linked to 4 different carbon in its neighborhood, and so on. So in this way, each carbon is linked to 4 different carbon, and they form a giant 3-dimensional structure, or we can also say a giant molecule is formed by the combination of these atoms by covalent bonds. Now some other example of covalent or network solid are SiO2. Okay, SiO2. Okay, you have aluminum nitride. Even you have SiC, silicon carbide. Okay, all these compound, they comes under the category of covalent or network solid. So thank you for watching this video.